Hi guys, in this video we are going to be deriving the long run marginal cost. That is, we're going to see how do we actually derive the long run marginal cost. Now guys, I've shown you over here, you can see that I've drawn the long run average cost curve, and I've drawn 5 different short run average cost curves as well. So you could say that this is your SRAC1, then you have SRAC2, SRAC3, short run average cost 4, and SRAC 5. Now these five basically, I've drawn these 5 different plant curves. Your plant curves also known as your short run average cost curves, and I've drawn only these five, which is sort of representing different plant sizes, and because for the purpose of my analysis only these 5 are enough, right? Now guys, look at the graph that you can see below. You have 5 different short run SRAC curves or plant curves, and then like I said, they're representing 5 different plant sizes, and then you also have your long run average cost curve. Now you can see that your short run average cost curve is tangent or tangential to the long run average cost curves at 5 different points. Let's call this point A, let's call this point B, let's call this point C, let's call this point D, and let's call this point E, right? And these are the points at which the firm will operate, if it chooses one of the quantities Q1, Q2, Q3, Q4, and Q5 respectively in the long run, right? And you see, all these quantities Q1 to Q5, these are basically the quantities which is representing the optimal utilization of your fixed plant capacity, right? So guys, now let's sort of turn our attention to the long run and see how the long run marginal cost curve would be derived. And for that, in order to see how that long run marginal cost curve would be derived, we will sort of first draw the short run marginal cost curves, right? So this is the same diagram. So guys, representing different 5 plant curves, which is tangent at these 5 different quantities. So guys, we know that the short run marginal cost curve basically cuts the average cost curve, short run average cost curve from its minimum point, right? It intersects it and passes up at the short run average cost curve from its minimum point of the short run average cost curve. So we're going to be doing the same thing, right? So let's sort of let's make the first short run marginal cost curve SRMC1, and then let's make another one which is SRMC2, and we are sort of intersecting them and passing them through the lowest points of the average cost curves, of the short run average cost curves, right? This is your short run marginal cost curve 3, and then you have your short run marginal cost curve 4, SRMC4, and then you have short run marginal cost curve 5, which is cutting through the lowest point of your short run average cost curve 5 as well. So SRMC 5, right? Okay, so basically now we can see that we have drawn these 5 different short run marginal cost curves, cutting the short run average cost curves from their lowest or the minimum point, right? Now you see, what we shall do is that we'll try to identify the long run marginal cost which is associated with each of these basically quantities. And how we're going to be doing that, basically, if you see that at a quantity of Q1 you have 1 point, right? So let's say at this quantity Q1, this gives us 1 point, we're labeling it point F, right? Then this quantity Q2, we're labeling it, let's say, point G, right? This quantity Q3, this is 1 point, we're labeling it, let's say, point C. Okay, so at a quantity of Q4, we will have another point on the long run marginal cost curve, which is this point, and I'm calling this basically point H, let's say, and this, and I'll extend it till here, and I'm calling this, let's say, point K, right? Now I have 5 different points: F, G, C, H, and K. So guys, although these points are basically on your short run margin, you'll see that from the diagram it appears that these points are basically on the short run marginal cost curves, but these are basically representing your long run marginal cost curves. These are actually points, because when we'll connect these points, we'll derive a long run marginal cost curve. So these are points on your long run marginal cost curve. So this is your long run LRMC1. So this is giving you the value of your long run marginal cost at a quantity of Q1. So at a quantity of output of Q2, which is being produced in the second plant, you know, so at this quantity Q2, you have your long run marginal cost is LRMC2, and then this is at quantity Q3, this is your somewhere LRMC3, right? This is your LRMC3. So, and so on and so forth, and then your long run marginal cost increases basically. So let's sort of erase this to sort of make the diagram more clearer. So guys, now what I'm going to do is that I'm going to be joining these points, right? So if I join these points, let's try to join this using a scale. So if I join this, if I join F to G, right, and then if I join this till here, and then like this, and then like this, and then like this. So now this is my long run marginal cost curve. So technically what I've done is that I've joined, so it's sort of like this, right? It's like this. So look at this. Okay, and then I take my, and then it's going like this, and then I've joined C to H, and then H to K. Now, guys, these are only 5 different plant curves, 5 short-run average cost curves. But just like that, we'll have multitude of short-run average cost curves, and with the multitude of short-run average cost curves, we will have multitude of series of marginal cost curves intersecting them um, from their minimum points, right? So guys, now moving forward, like so that's how you basically derive your long run marginal cost curve, by connecting these points, right? Now guys, I just said that we demonstrated this long run marginal cost curve, or I created this long run marginal cost curve by just connecting these 5 points: F, G, C, H, and K. And I want you guys to sort of imagine right now, just like we imagined with the long run average cost curve, that you can imagine with for the long run marginal cost as well, in order to create the long run marginal cost curve. So you can imagine that if we sort of find the long run marginal cost, if we find the long run marginal cost, because this is the look at this point F, through point F we found the long run marginal cost at a quantity of Q1. Then through point G we found the, because this point G was representing another point on the long run marginal cost curve, and then point G was representing another point on the marginal cost curve, and Q for a quantity of Q4, at a plant size with a maybe large, with a obviously definitely larger plant size, with having a short run average cost curve on a different plant curve, on a different plant curve, that is SRAC4. So we can, point H is basically representing, we can find from the point H we can find another point on our long run marginal cost curve known as L, which, and its value would be LRMC4. So on the vertical axis you have basically, on the vertical axis we're measuring, you could measure your long run marginal cost, right? We're measuring your long run marginal cost, the value of your long run marginal cost on the vertical axis. So having said that, what I just said was that, if you imagine that if you find the long run marginal cost which is associated with every possible quantity that the firm could produce. So if you mentally imagine that, you're trying to find the, if you mentally imagine that we're trying to find the long run marginal cost which is associated with every possible quantity that the firm could produce over the years. So what we can see is that we could mentally imagine that we will have a series of multitude of short run marginal cost curves which will be crossing the minimum of the multitude and series of short run average cost curves. And if we connect those points, then if we connect all those dots, right, if we connect, so if we have these series of average cost curves, and then in the series of marginal cost curves cutting down those average cost curves at their minimum points, and if it, and if with that being said, at every plant curve, imagining that there are a series of plant curves, there would be a point that would be tangent to the long run average cost curve, which would be the optimum quantity being produced at the tangential part, representing, representing that this quantity is representing the optimum utilization of your fixed plant capacity, right? Because you see, beyond prior to this prior to this point, your average cost is low, sorry, your average cost is high, meaning that you still have vacuum to produce more output and reduce your average cost, and benefiting from increasing returns, right? And beyond this, your average cost is going up, so this is representing your optimum utilization of your fixed factors, right? Because before this, you have increasing returns to variable factor, and beyond this you have decreasing returns to variable factor. So if we imagine that, right, if we imagine that, so if we imagine that, like I said, if you imagine that with a series of multitude short-term marginal cost curves crossing the minimum of the multitude of short-term average cost curves, what we will ultimately get a smoother curve, which would something look like this that I've shown on the left. So you see, you'll have a smooth long run marginal cost curve, again crossing the minimum of the long run average cost curve. Now, before moving on, I want you guys to know, what I want you guys to know is that students make a mistake here, because you see, you need to understand that this long run marginal cost curve is flatter. So I see, when I'm checking the papers, I see that students draw the long run average cost curve like this, and then they draw the long run marginal cost curve like this, because you see, this is how the short run marginal cost curve is. You can't make this distance so evident, right? First of all, how you will draw it, you will draw it like this. So that's how you need to draw the long run marginal cost curve, and this is one of the properties of the long run marginal cost curve, or the feature of the long run marginal cost curve, that it's flatter. Okay, guys. Now, as far as the relation between your long run marginal cost and long run average cost curve is concerned, that those relations are similar to the relations that were between short run average cost and short run marginal cost curves. That is, when the long run average cost curve is falling, the long run marginal cost is obviously less than your long run average cost curve, which is pulling the LRAC down. And then when your LRAC is rising, the long run marginal cost is greater than the long run average cost curve, pulling the average up. And at the minimum point of the long run average cost curve, that is this point, right, the LRAC, long run average cost, is equal to the long run marginal cost curve, and because at that point the long run marginal cost curve cuts the long run average cost curves from below, right? Now, guys, before we conclude this video, there's one more important thing that I need to tell you regarding the feature of the long run marginal cost curve, and that is that the long run marginal cost curve, guys, is much flatter as compared to the short run marginal cost curve, which is steep, right? So this is how the long run marginal cost curve is, right, as compared to the short run marginal cost curve, which is quite steep, right? And the simple reason, and I've written down the reason here as well, just so that you guys could sort of take a deeper understanding of this, is because in the short run, what is the problem with in the short run is that the firms are constrained, they're restricted, in the use of their capital, which is fixed. And in the long run, however, if the firm really wants to expand, if it wants to produce, let's say, even one more unit of an output, the firm is sort of, it has a free hand to vary the amount of capital they could expand, right? They could open another plant or factory, or they could even increase the amount of labor or any other input that they use, right? And they could do so using the cheapest possible combination of inputs, right? That is using the optimum mix of inputs, and in order to produce that single additional quantity in the long run, right? And because of that reason, that makes the long run marginal cost curve much flatter. But in the short run, we know that, however, in the short run, the firm doesn't have this freedom, because it is constrained. That is important, you need to know. It is constrained in its use of capital, and hence, as a result, what happens is the long run marginal cost, but this doesn't apply in the long run, and as a result, in the long run, what happens is the long run marginal cost curve is increasing at a slower rate, right, in comparison to the short run marginal cost curve, and that makes the long run marginal cost curve flatter, right? So that's it, guys. Thank you so much for watching my video, and I'll see you all around in the next video.